And here is our mole expert, Mr. Hevel.
That's right. Yes, indeed. Using our mole knowledge and everything at our disposal here to do a mass percent composition lab. Okay. So, let's see. What we're using is potassium chlorate. Okay, we're going to heat this up, and it's going to decompose. All right, and we can use that decomposition and the change in mass that occurs to then help us calculate a mass percent composition. That's the basic idea here.
Yeah, there's 3 elements in potassium chlorate.
That's right.
And I think we only want one of the 3. If we can find the percent of oxygen,
Right,
then
that would be fine.
Yep.
Yep. So that's actually what happens when we heat this up. Potassium chlorate, KClO3, is going to decompose into 2 things: potassium chloride, KCl, and oxygen gas, O2. And so there'll be a mass change before and after heating. That difference is the oxygen that's been driven off.
Mm-hmm.
And we can use that information then to get percent of oxygen by mass in potassium chlorate. So one thing we're going to have to know is the mass of the compound that we're starting with. Balance zeroed in here.
That balance is being stubborn. It's jumping all over the place.
Oh, it is. Yeah, this one goes out to the thousandths place, so it's pretty sensitive. Can't breathe on it. Okay, seems like it's pretty stable.
Mm-hmm.
Ooh, a little too much. We're trying to use somewhere between 1.5 and 2 grams, or something close to 2 grams.
That'll be
That
fine.
ought to work.
Yep.
Okay, so there's our starting mass of potassium chlorate.
We'll stop moving here for a moment while that finds its mass. Good. We'll also want to have the mass of the dish,
Yep.
evaporating dish.
And so we're going to heat potassium chlorate because it's going to get up to a pretty high temperature. In a porcelain cup, or dish you could call it, it's called an evaporating dish. We'll need to know the mass of this. Oops. Zero it out.
Yeah, because the product will be in the dish at the end, and we don't want to try to scrape it out. Just when I think, okay, we're done.
Mm-hmm.
$84.248. We're going to stay with that.
I think that's pretty close.
Okay. All right, so that's the mass of the empty evaporating dish.
Yep. So what we'll do then is we'll add our potassium chlorate to that. Make sure it all falls into the dish. And essentially now we're going to heat it. And to do that, we're going to use a Bunsen burner and a ring stand and a clay triangle that will hold the evaporating dish.
Mm-hmm.
So let's get the burner started. We're using a Bunsen burner lighter, makes a nice spark. Okay, and I don't know how well the flame shows up.
Yeah, we can see the flame.
Can you see it?
Yep.
So if we haven't had a chance to use a Bunsen burner, if you lower the barrel all the way down, you cut off the oxygen supply, and you get the coolest possible flame. It's just yellow. There's a lot of gas that's really not even burning because there's not enough oxygen coming in. And then as you raise the barrel, you let some oxygen in the bottom here. You get a hotter flame. It's blue now. we're gonna keep going. So we want to get the hottest possible flame, and the tip of that inner blue cone is the hottest part of the Bunsen burner flame.
Mm-hmm.
And so we're gonna try to set that under the dish.
This is a cool reaction too, because all ionic compounds are solid at room temperature. And this is a case where the solid is going to melt down. A lot of ionic compounds will just decompose. This one does decompose, but it will melt first. You get molten potassium chlorate.
You have to be careful we don't melt your iPad.
Yeah, we don't want molten iPad.
Could throw off our result.
Yep, it's starting. Kind of see there at the edges.
Yep. There it goes. So it's going to melt, and it really almost looks like water, but then it's going to start bubbling quite a bit, and all that bubbling is the oxygen that's being driven out.
Mm-hmm. Yeah, it kind of gives the look like it's boiling, but it's not boiling. You're right. It's the oxygen that's given off.
Our Bunsen burner is a little anemic.
It sounds like it's working hard.
It is.
Yeah, see that bubbling in there?
Is the bubbling showing up?
Yeah, we can see the
Yeah.
bubbling.
Okay. Some off on the edge here.
Yeah, it gets nice and hot down there, as you see.
Mm-hmm. Red hot.
So yeah, the bubbling is the oxygen going away. And this is really cool because once all the oxygen is gone, then we have just potassium chloride in there, and it goes back to solid. That's how we know that it's done.
Right. Potassium chloride apparently has a higher melting temperature, so it just solidifies. I'm fond of saying this is like watching the grass grow.
Oh, this
This
is
is the chemistry.
this is
version
real
of that.
chemistry.
That's right.
You don't want to miss this. If we were nice, we would just stop the camera.
Right, but we wouldn't want
That
to
didn't occur to us, though.
Yeah. Raise this up, you think?
Just make sure it doesn't soften our triangle too much.
Might. There we go. That's speeding things up. Now you can see it bubbling. Really good.
Mm-hmm.
Okay, once that oxygen goes, it's going to solidify pretty fast. Quite a bit of oxygen in there. When you
There's
look
a
at the
lot,
compound,
yeah, for sure.
it's always kind of amazing how much oxygen is in there.
Mm-hmm.
Which is one reason why I believe the most abundant element in the Earth's crust is
It's
oxygen.
oxygen, yeah. Oh, I think something is happening.
Yep, you can see there goes the oxygen, the last of it.
Yeah. That's it.
Okay,
Ah, very nice.
there we go. So it should just be potassium chloride, KCl, left after the heating.
Yep.
Now we're gonna have to let it cool. We can't just take it off and put it on the balance immediately.
Yeah, Mr. Hevel is tough, but I
Yeah.
don't think I'm going to ask him to grab onto that
Right.
dish now.
We'll let it cool down and get back to you.
Okay. So now we have let the potassium chloride cool off.
Mm-hmm. Yep, I don't know if you can see before, that white substance in there is potassium chloride, and that's what's left when the oxygen is driven out. So now we need the mass of the dish and the potassium chloride.
Yeah, so this mass has the evaporating dish and the potassium chloride. What are you going to do with that so you can just get the mass of the potassium chloride?
Yep.
Okay, and from this, I think we can calculate the percent that oxygen made up of potassium chlorate.
That's right.
Good luck.